Hello, everyone, and welcome to the first ever Trafalgar LinkedIn Live discussion session with myself, John Henry, and John Rackick. Some people call us Tall John, Short John, Happy John, Grumpy John, Skinny John.
Big John, Small John, Fat Controller.
And the reason we're doing this today is ducts can be quite complex, fire controls and smoke controls with ducting. And there's a lot of history and there's a lot of embedded knowledge in AS 1668 and the standards and codes, as well as in John's brain. So I'm going to actually hand back to John Rackick to take this session. I'll be watching the LinkedIn comments for questions if you have any. Take it away, John.
Okay, thanks, mate. So what we're talking about today is the when, why, and how around fire. You know, most people say fire-rated ducts, but it's important to think about fire and smoke control ducts in the context of NCC and 1668 Part 1. So it's quite a complicated subject, so I've tried to break it down as simple as I can. Of course, we will play a recording of this or make it available to people, so you don't need to take too many notes. Down. Oh, I don't like mouse. Okay, so why are we really talking about it today? Most of you would know by now that there were some changes to the NCC around the grandfathering or grandmothering, if you like, of test reports. So as of the 1st of May just gone, all fire testing has to be to 1530 Part 4 2014. So it's a major change. A lot of old systems are redundant or need to be redone. So there's been some press about it. Here's an article that ERA published trying to give the market as much time. We've had plenty of time, but as much time as it could to get ready and to adopt the change. So first and foremost, I guess I asked myself, why do we have ducts in buildings? So let's not think about fire and smoke ducts at the moment. Just think about it yourself for a minute. Why would we have a duct in a building? It's pretty simple. You should have got the answer yourself. We need heating, ventilation, air conditioning. So in the winter, we like to be warm, and in the summer, more importantly, we like to be cool. So those ducts, sadly, it's a nature of a centralized duct system, go through all sorts of areas of the building. And of course, in a fire, the smoke in particular, and in some cases, very, very hot gases or fire can spread. Having been born on November 21st, it's ironic because I'm into fire protection, but back in 1973, when I was 7, there was 85 people killed in the MGM Grand Hotel Resort, hotel casino resort. You just look at the statistics here, 85 deaths, 650 injured, including firefighters, guests, employees. So when we talk about a non-rated or a conventional duct, we typically, most people would know, where they pass through fire barriers or smoke barriers, we have fire and smoke dampers used to control or minimise the spread of fire and hopefully the spread of smoke to a degree. That's not what we're talking about today. We're going to talk about dedicated or special ducting that's in the building that typically only has a function when the building goes into fire alarm mode. So we all know or should have heard that in most buildings, it's not always the case, the lifts go to ground floor. So if you're waiting for the lift to exit the building, you'll be waiting a long time and you need to use the stairs. Of course, if the non-rated ducting, we've talked quickly about the fire dampers or smoke dampers through fire barriers, we'll sort out the non-rated ducting, but we're talking about these special fire and smoke control measures which use ducting. That's what today's about. So there you go. We're talking about that, not that. So we're not going to talk about dampers. If people want a damper presentation, we're happy to do one. So in the comments, you can ask us what you think you'd like the next LinkedIn Live to be, where we'll go with the masses, and the most popular one we'll do next, but we plan to do more of these. So in terms of ducts, from a first principles point of view, whether it's a fire-rated duct or not, if it has to do something special in fire, you can see it could spread fire, it could collapse. You can think of the basic things that you want it to do or it needs to do. I just thought they were interesting pictures, if nothing else. So we're talking about these dedicated fire and smoke control measures, and they live in AS 1668 Part 1 or AS NZS 1668 Part 1 to be specific. And in terms of the ductwork itself, if you want to break it down into simple building blocks, you have exhaust systems, which suck, pardon the pun, and you have supply air or pressurization systems that blow. So just think about the sucking and blowing or the exhaust or pressurization systems, and we'll talk about how the test methods and everything come together around those two basic pillars or building blocks. So here's a scenario. You might find in a building that you have a cooking area or cooking areas or some sort of exhaust system, whether it's car park exhaust, kitchen exhaust, all sorts of exhausts. And here we show some ducts. This is just a snippet out of 1668 Part 1, where the ducts might be exhausting from a compartment here, having to pass through another compartment into the fire-rated riser and exhaust out of the top of the building or outside the building. So if you imagine now from a first principles point of view, knowing that a fire damper, mechanical or intrumescent one, is activated by heat, and we put a damper right here, hopefully you can see it, or I'm guessing they can see the thing, Johnny? Yep, good. If we put a fire damper here and the hot gases came in, it's going to close and we're going to lose our exhaust. So we won't be able to suck. Or we will be able to suck. It will suck, if you pardon the pun again. So in these particular ducts, you won't use dampers. And that's why they have to be continuous and be fire rated, so that the fire could go in here, the hot gases could suck through here, go through this fire barrier and get out without causing reignition or the fire to spread from where it's coming from into the apartments it passes through. So hopefully that makes sense. Pressurization is pretty simple. I like to use analogies. What you have to think about here is we're using air to pressurize parts of the building for smoke movement purposes. So as much as the ducting may need to be fire rated, this is for smoke control purposes. So what we have here, if you look at it, I've tried to use different colors to make it simple. Imagine this is the fire floor as it's shown here. And we're supplying air, and we need a big fan, and we don't want to, if we supplied air to, first and foremost, if we supplied air to the fire affected floor, we'd make the fire worse. So this motorized damper will close, the rest of them will close, and only the ones above and below the fire affected floor will open. So you can see here we're a design pressure of 20 pascals. And what that's doing, and of course this one opens to allow the hot gases to get out of the building. And so I use the analogy that if you're a smoker and you try and smoke and blow smoke out of your car while you're driving, the pressurization of the outside to inside of the car will typically blow the smoke back onto you. So that's what we're using. We're using pressure differentials of air to pressurize the building. So that's a different scenario. So that's the pressurization or the blowing side of it. So that's just fundamentally the two different applications that we deal with in fire and smoke control to do with buildings in 1668 Part 1. So just like everything else, I mean, feels like John probably feels like me after all the years of presenting. We just seem to just keep saying the same message, that FRL belongs to a system, to an assembly, not to the individual parts or components. And the only way you really know if it works is to fire test it, at least for the deemed to satisfy criteria. So some of the components are building up the bits and pieces that you need to start thinking about. If you're going to design a fireproofing material or a fire-rated duct system, you need ductwork, of course. It's got to be the ductwork that the fireproofing goes on. So the smart manufacturers will use the Australian standard for duct construction because that's what people should build to. You'd have to think about the types of joints and how the duct fixes together and how that interacts with the fireproofing materials. And you'll notice materials here, because if it's a wrap, for example, you might have sticky pins or some sort of way to fix it. You might have straps, sealants, yeah, all sorts of stuff. Of course, if the duct falls down, it's got no chance of exhausting or pressurizing if it's in a fire affected floor. So that whole way that it's supported from a concrete slab, for example, is important. And if it goes through a fire barrier, that part is basically a penetration. It's important that on the other side of the fire, the penetration isn't the weakest link. So I just want you to think for a minute, have I missed any? Or are there other things you might need to consider when auditing or thinking about what makes up a fire-rated duct system? John, can you think of any?
Probably access panels.
Access panels is a good one, yeah. Yep. Well, I've done the thinking for you, not definitively. There you go, number one. The new it's the most readers have come up with that show, what is it? New Price is Right or something?
Oh, yeah.
Yeah. The number one answer is fire-rated ducts.
Because I know kitchen exhaust ducts need an access panel every 3 meters.
Oh, yes. And why do you think that is?
Cleaning.
Yeah. We got to get the grease out because we don't want a grease fire. We don't want grease building up for cleanliness and all stuff. So I like to say that at the end of the day, it's fine to do all this technical stuff and to have a test method and try and put it in as identical to tested method. But we live in the real world, don't we, Johnny? All our questions are a real world application of it. So you could imagine you have a duct that's very close because of space and head height to the soffit of the slab, and you might not be able to spray in there and get wrapped. So you've got to develop and fire test systems for that. You might have a vertical duct in a corner. We have out-of-line fire dampers, so the damper's not in the wall, so it's suspended by inside the duct. Oversized openings, we never make the perfect hole, so you need systems to deal with the duct that goes through a bigger or an ugly hole, which happens all the time. And services, plastic pipes, sprinkler pipes that interfere with the fireproofing. That's some of the examples that I can think of. And a big one is the smoke exhaust fan. So if the smoke exhaust fan happens to be an axial fan and it's not in a plant room and protected, if the smoke fan stops sucking or the pressurization fan stops blowing, our whole smoke control and fire and smoke control philosophy dies. So we need to protect the fan, and more importantly, the fan moves with vibration. There's always some sort of flexible bellow, or I guess a bellow is a good name for it, or a joint or a connection. A connection, yeah, there you go. So I've put this into a system. So a fire-rated and smoke-controlled duct system. They're the little pillars that I think, as a minimum, need to be thought of. And I'll just quickly go through each one to give you a flavour. I can't take hours to do it definitively, but we're trying to give you an idea about how to design, how to certify, and how to feel comfortable that you're doing it right.
Can I jump in with a
yes,
question
please.
from the audience?
Yes, a question from the audience.
So Michael's asked, AS45 for ducts are not fire rated, are they?
No. Yeah. Very good question.
And this demonstrates why.
Yes, that's a very, very good question, and hopefully we cover it in a bit more detail as we go through. But no, we like to take a 4254 construction. And of course, there are other things we need to do to the ducts. When we talk about duct construction, I think your question hopefully will be answered, Michael, but let us know if it's not. Good question. Quite often the questions will be 2 or 3 slides later, but very good question. So let's start with the juicy bit. We all love, well, John and I love burning stuff. Let's start with fire testing. So, as I said, there are some changes. 1530 Part 4 2014. It's been around for a long time, but it's the adoption of it. There were some old test reports and some strange editorial mistakes that meant that the thicknesses will need to change now, and hopefully we'll talk a little bit more about that. What we're seeing is that this is a tough market. There is a lot of fire testing, a lot of money and a lot of knowledge needed to play in this space. It's not for the faint-hearted. So at this point in time, we have two systems, our monocoat fire spray, which is we've been working on for the last three years, and we brought to market recently. And of course, Fire App, which many of you might know. But this is not really necessarily about Trafalgar. This is about providing some knowledge. Jimmy, how do I get rid of that so I can actually see? Something's changed, hasn't it?
Yeah, I think it's going to stick there.
That's okay. That's okay. We'll just have to talk over it. So when you talk about, I really dislike an FRL. I think it's convenient for regulators to try and have a one size fits all, because when you have structurally only elements, you'd only see this first criteria, and people inadvertently say 120, 120, 120 when they mean 120 dash dash. But if you just think about these criteria and what they're trying to do, if we talk about structural adequacy and try and think of it in terms of a fire-rated duct, my brain says that there are two main things we're worried about. The duct must stay there, so the suspension system needs to be tested to exposed fires, 1530 Part 4, 2014. And if you're doing exhaust ducting, it's in there, but people don't really think about it. If the part of the criteria is that the cross-sectional area of the duct must remain at least 85% of where it started. So you can imagine if the duct starts shriveling and it passes the test and does everything, but the cross-sectional area is tiny, we lose our exhaust capacity. So that makes sense from a first principles point of view to me anyway. Integrity in terms of ducts, I would say, is more about the efficacy or the material being able to deal with the heat, the expansion, the distortion, and of course, cracking, falling off. And it also applies to when ducts penetrate through openings. And insulation, I really think the NCC should reconsider this term. It should be called temperature rise, because that's what it's all about. It's the insulating performance of fireproofing materials, fire stopping materials, and it's all about temperature rises. So when it comes to ducts, the temperature rise for help me with this, John, for an internal fire, we're exhausting it out of the building. We're really worried about what's happening outside. So if there's combustibles close, we don't want Newport Arms, just near me, caught fire recently, and the barbecue area for the pizza oven caught fire because the combustibles were too close to a duct that wasn't properly protected. It probably didn't need to be protected, but it is what it is. And of course, if we're supplying air and the heat gets into the duct and we're trying to blow pressurized air into areas where people are occupying it, we don't want the air to get hot. So that's an important characteristic, I guess. So that's just a little bit, you can come back. So, I talked about this blowing and sucking. So if we think about from a first principles or probably from a pragmatic view, when we're dealing with internal fire exposure, it's typically aimed at exhaust ducting, not exclusively, but I would say that is a pretty good statement to make. And when we're dealing with external fire exposure, we're worried about supply air ducting, because we don't want that air to heat up to blow hot gases or hot air, into occupied spaces while people are escaping. And I'll go through that in a bit more detail. And you'll see on pretty much every slide, I keep saying the determination of the system, not the components, is based on an FRL. So we can only make claims and say what we say based on real tests. And we did, I can tell you honestly, we didn't get it right the first time. We learned. And we learn the hard way. It's expensive exercise at times. So internal fire exposure, you can see here, we're exhausting hot gases up or out of the building. And of course, the fireproofing materials, there's no fire damper here. That's why this penetration is important. So the heat doesn't sort of come through here and get into this space and light up some combustibles. So that's a little pictorial that might help you visualize that. And you can see these red arrows. This is hot smoke. If we're pressurizing a space, it might be a fire stair, it might be zone pressurization, which I'll talk more about, or sandwich pressurization. or corridor pressurization, we don't want this air to heat up. So when we're doing the fire test, we're measuring the temperature of the duct and the exhaust air for external fire, which makes sense. Then we can apply that data to the real well. So here's a penetration test we did. Obviously, I thought it was a really good photo to show you where we're changing penetration details for already tested ducts. And you can see here, this is internal exposure for an exhaust application. You can see our maxi-light board here, how hot after 2 hours the furnace is when it's just been pulled off. And you can see the guys here, obviously this is a pretty good material and a good result, because the guys are actually, looks like, might even be your hand, Johnny. It looks like people are there when you've got 1,000 degrees here, you know. So that's what we're talking about. And just to reiterate again, you know, you don't want, this cross-sectional area is important. You can see here that the duct looks pretty much, certainly more than 85%. External fire, you can see here, you know, you do these, typically you do your baseline duct tests, in a 4x3 furnace. So here you've got 2 different ducts being tested. These ones happen to be fire wrap. Before and after, I want you to focus on the suspension system. It's a question that comes up all the time, is, you know, do the hangers need to be sprayed, or do they need wrap on them? What size do they need to be? Because 4254 will not tell you for them to be that size, but it'll tell you how to do it. And what material the ducts need to be made out of. So that's a point just to keep in the back of your mind. So there's some photos of some real testing just to give you a feel for it. We'll now move on to duct construction, and hopefully, so the duct, you know, a lot of people think this, and I learned a lot about fire door frames. You know, people think the thicker you go, the better it's going to be on fire. But the thicker you go, and the hotter it gets, the more the thermal expansion is you have to deal with. So thicker is not always better. In fact, in terms of sheet metal, and I've been burning metal things for a long, long time, a thinner duct is actually quite good, but it's obviously got to perform. It's got to do all the other things it needs to do as a duct. So, of course, as the ducts get really big, 4254 talks about tie rods. You know, you might have a duct that's big enough. In the Opera House, we're walking through the ducts there. They were that big. Yeah. And they have to be trafficable and all sorts of things. So what's important is to know what types of connections are tested, and if there are any special details before you connect the ductwork up. If you can provide a system that makes it easier and there's no special things, then of course it's going to be easier to sell. So it talks about snifting bars, joint types, and bits and pieces. We'll move on to the duct suspension system. And I always said, you know, everyone calls it a trapeze, because if you think about it, let's look at the shape of that there after it's been burnt for 2 or 3 hours. It is a trapeze. So what is important, just like a fire collar is no good if you put it up with nylon plugs and screws. It needs to have a fire-rated anchor, or the anchoring system has been tested. So that's important. The size of the threaded rod, the load that's on it, and the size of the trapeze. So if you've done enough fire testing, like we have, you own a portfolio of data for 2, 3, and 4 hours of what the stress or the load on the duct needs to be before fire, so it'll stay up in fire. It sounds a bit complicated, but that's how it works. So this term that I invented all these years ago about a self-supporting fire-rated duct, I call a self-supporting fire-rated duct one where the suspension system is unprotected. So it'll self-support its own load and not collapse during a fire. So, of course, if you think about it from a first principles point of view, if I clad this in concrete, it would be very heavy. So I'd very quickly need much bigger threaded rods or much bigger spacing. But things, you know, if you take a fire spray, it's around a dry density of 350 or 450 kilograms per cubic meter. Fire wrap around 96. You get a lot of advantages because you don't have to drill as many holes and you can extend your spacing. So all that sort of stuff is in our design manuals, and of course we can always help people with that. We seem to do it more often than not anyway. So just think about that trapeze, and just think that you've got to look at the tested systems. There's a lot of people that just don't provide the details, and their systems actually do need protection. We're happy. We know that in the real world, no one's going to put them on, so we've tested that way. We'll now move on to applied fireproofing systems or materials. So looks like a thesaurus, and so it should be. It's so easy to fall for a trap of designing a product that passes a fire test. But at the end of the day, let's hope that it never, ever needs to be in fire. There's a whole lot of other things that may or may not be important. Some of the ones that John and I came up with were that it goes without saying that you wouldn't pass the fire test and you wouldn't get the criteria if it can't stay in place for the duration of fire exposure. So stickability, structural adequacy, call it what you like. It's got to deal with expansion and contraction in fire. R values are important. Acoustic values are important. People don't like the noise. If we're pumping cold air down a building and we're getting a lot of thermal loss, we're burning a lot more greenhouse gases. So R values, as we know, Section J of the NCC is causing all sorts of grief to people. There's a whole lot of talk about, have we gone too far? What's happening? It's got to be good. It's actually imperative that it's safe for the people that are applying it. Sustainability is coming in. Some architects might not want to conceal it, so aesthetics might be important to them. Impact resistance might be important. If it gets knocked with a ladder or a forklift or a car, I think of sprays when I think of that. There's a place for every product. Coordination of trades on a building site. Think of, or whether it's made off-site. I think one of these talks about off-site, speed of installation, off-site construction. That might be an issue. Speed, the faster we build, the quicker we get a return on, as a developer, on the apartments, because we can lease them out or we can sell them. Cost of material and the as installed systems, seismic movement. I'll just throw it in there. I didn't think of that. That was you, Johnny, wasn't it? Probably vibrations and vibration. Yeah, you can think this is just to give you a feel. It's not just about fire. It's very important, but the materials that you'll find in the market are fire sprays. Thanks to 2009 duct wraps now. Fire wrap's pretty special product to me. I just love it. I just thought it was fast, clean, and easy. And looks good, easy to repair, light, and boards, of course. Some people might ask the question about intumescent paints. People have done tests with intumescent paints, but they get red hot, and within 5 minutes, the intumescent paint's fallen off, and the duct's changed its cross-sectional area. So be careful if you. It's very popular in some Asian countries, but I think it's a little bit of a misnomer, that one. Access panels, there's no point putting a duct in and then just throwing a field applied access panel on it. When we started with Fire Wrap, we were looking at what they do in the States, and it was a field applied access panel. People bolting things together, it's complicated. I didn't think you'd get it right. So we developed our, what we were calling our Fire Wrap access panel. We've done the same for sprays, and we've tested it in the system. You can see here thermocouples and stuff during testing. Some of this stuff was for the off-site market, where the connections, when it's put in drop-in risers, that's the real world stuff we're talking about. And it's got to be tested, obviously, in both orientations, depending on where the duct is used, sucking, blowing. Trying to move on, conscious of time. Openings through fire barriers is pretty simple. We're talking about, we don't want a problem. Let's try to draw up a very dodgy plasterboard wall there, Johnny. This area. There's no point having all this working, and we find that it all fails here, and this gets too hot from this side to that side or any other apartment. So it's more like it's going back to conventional fire stopping. And again, determined by fire testing. I should be saying that each time, but I said that earlier. Real world applications, we touched on some of them. there's plenty of them. They come up all the time. People say, have you got this? Have you got this? Can you test that? And then, of course, the more the testing you do, the better your field of application, the more comfortable people are using your products. So that's the way we roll, and that's why we're always fire testing. So here's some details. Johnny, what have we got here? What's this one up the top right?
This has been pasted over.
Oh, has it?
But it's
Okay.
the ducts up against the slab.
Oh, duct. Yeah, details for ducts hard up against the slab, access panels, outer line dampers. You know, sprinklers getting close. There you go. Yep.
Penetrating inside the ducts.
Wow. Oh, yes, the ducts inside. Oh, I didn't even know we had that.
Yep.
Yeah, busy little beaver.
There you go.
There you go. And good workmanship. I really want to put this here because spent our whole life burning stuff. You know, at least with modern technology, I know when I'm fixing my push bike and I'm on the road, if I've got service and my something happens, I will pause the YouTube, do one thing. Might be doing it in my garage, go and get a coffee or a beer, come back. You know, it's so easy with technology to have videos. Because a picture tells 1,000 words and people can misinterpret words. So I think videos and, you know, it's nothing, people still like the old-fashioned written words, but I think that's really important to communicate what you're doing because we know what we've fire tested, and it's a duty of care for us to give everybody who's buying our products and turning them into the systems, Johnny, to make sure they can do it right and do it right the first time.
Yeah.
We're really passionate about that because there's nothing worse than a strata owner owning an apartment only to find that he's just moved in and there's problems. He's bought a new building. So that's what makes us tick, man, John. We just want to solve the problems and try and do it as cost effectively as we can.
And the products themselves, materials, if you watch the videos, are relatively easy to install. They're not difficult, but you just got to make sure they're installed following the instructions to the letter. Because if you deviate from what's tested, that's when you get defects and non-compliance.
Yeah, and there's no excuse not to get it right.
Yeah. And I'm not a tradie. Yeah. And I've installed some of these tests and they pass. If I can pass the tests, it gives everyone a fighting chance.
Well, let's not forget Chris Todd.
And Chris
we call Chris Todd Abdullah the Butcher. Because most of the things we have when people say I've made a bit of a mistake, it's because Chris has made those mistakes and we've fire tested them and they're the get out of jail cards. We don't, they're there. So ring up if you're stuck, because that's where we really cut our teeth and differentiate ourselves with real world technical advice with all your 6 or 7 engineers that work for you. So you'll find in the Knowledge Centre of the T-Fire website or on the product pages, it's try to make it easy for you. There's the how to install fire wrap. We're doing the spray one. We've got spray ones. There's just about everything you want. And of course, for certified, it's really important to double check or have a look at test reports. It's all up there. MSDSs, you know, we're trying to make it easy. So if there's anything we haven't thought of to put on our website, we'd love to hear from you about that. NCC and Australian standards, you know, I started at 1 o'clock. I'm getting to 12 o'clock, coming to the end of the presentation until we start. We'll do a little bit about what roles does everyone listening or anyone who watches this replay, what role do you play in this? Because we try to play our role, but we all, whether we're a certifier, whether we're a designer, whether we're the builder, developer, everyone's got a role in getting it and working together to get it right. So, you know, take it as gospel. 1668 is called up in the NCC, and we're talking about, I didn't say it, but it was in the presentation, Class 2 to Class 9 buildings in Volume 1. That's what that's about. And it talks here. If you look at the title, the use of ventilation and air conditioning in buildings, fire and smoke control measures, right? So that's why it's fire and smoke control ducting, exhausting, pressurization. What's happened if I've gone backwards? No, I haven't. Okay. So this is the bit where I think, apart from being able to go back over that and have, I'm sure people will have questions, I want to talk about design and certification of these smoke control ducting, fire and smoke control ducting systems. And I don't have all the answers, but I think I know what needs to happen. I mentioned Dave Chandler. I like to quote Dave Chandler because he said it's regulators and industry that are collaborating and need to work together to make safer buildings that are built right the first time. So it's no different here. So in terms of design, who designs them and how do they do it? All right. So I think mechanical services consultants who are trained to deal with 1668 and to look at fan sizes, to look at duct sizes, to have a little bit more detailed specification of what we see today. I'm not saying, some of them are pretty loose because construct and then design rather than design and construct. It's probably really important to get this right, because this is where you can save a lot of money or cost yourself even more money if you're a builder or a mechanical services contractor. So the mechanical services consultants have a huge role to play, and it's the rules which they play with are in 1668 Part 1. So they'll have an interpretation, as will the certifier. So getting the certifiers involved, because they're on a project early, and including them as part of not the design team, but understanding that what their interpretation is what's your interpretation, and getting in early so there's no surprises is probably pretty important. So who does the certification? And I'm talking about the certification of the whole building. And the building surveyors will certify, the building surveyors, also PCAs in New South Wales, will be looking and interpreting the NCC and this standard as well. Separate to where maybe a mechanical services contractor who has to certify that all the fire and smoke control ducting complies. That's a sort of a, I like another name for that. It's like it's almost like it's a different type of certification, but it's important, I guess, contractually to sign off. So this question is important. What's changed in 1530 Part 4 2014? Why does it matter? Why are the old ducts redundant? And are they redundant? Do the thicknesses change? And you ask yourself from first principles, I've sort of talked about sucking and blowing, but when do you need internal fire exposure only? When do you need external exposure only? When do you need both internal or external fire exposure? And who determines it? And what is the FRL for each different type of duct and building? What I will say is that after about 2005, we've had it easy for nearly 20 years because the fireproofing materials for both internal and external exposure were pretty similar. So everyone just said, we'll just spray that thickness and we'll get two-way fire protection. But if I was to tell you now that one of the ducts with the new criteria is a lot thicker of fireproofing material, pound for pound against the other, and that's going to cost a lot more to apply, you might go back to your mechanical services consultant and get a better definitive answer rather than just taking the least path of resistance because it's going to cost more money. Probably really good to us, Johnny, because we've got a lot more fireproofing material.
Absolutely.
And you told me not to say that, didn't you?
Don't know what you're talking about.
Oh, that was the commercial team, sorry. So which exposure is thicker, internal or external? Anyone want to type up a result quickly and we won't embarrass you? First person to do it gets fire spray all over them. How about that?
I think we've got a short delay.
Okay.
A minute or two.
Oh, do we? Is that what it? Oh.
Yep. So I'll read out any comments that come through.
Okay. Anyway, it's not easy. It probably doesn't even make sense. I think the test methods are what they are. I agree with the test methods. I think the test methods are very conservative, but that's probably just the way we are. It is deemed to satisfy. Doesn't mean we can't play around with performance designs, and we've got plenty of data for that. If people do want to do it a little bit differently on big projects.
All right. So Gavin said external fire. He thinks is the.
He's right.
Yep.
And he should know too. Mr. Williams. Hello, Gavin. Thank you for listening in. He is definitely right.
And then Carl as well said external, and he said higher surface area, question mark. So should we explain why? It's probably more the exposure.
No. I go right back to when we tested external ducts without any air velocity in them. So it's still probably never happened. You would hope that your smoke control fan goes, if it's not blowing, it ain't going to blow anything hot if it stops. So AS 1530 Part 4 2014 uses 1 meter per second. Any mechanical services guys that watch this later or are listening to it now will know that the design velocity is much higher than that. So if we're measuring the air temperature, the faster the air moves, the more it cools the duct because it's cool air coming from the fan. So 1 meter per second is quite conservative. And I guess it just works out that way now. I don't know if there's any logic. I'm sure if you increase the velocity to 2, it will change, and at some point 3, and you might find that then the external thickness is thinner than the internal. But it's not a huge difference, but it's certainly a lot different than it was previously because there was actually a loophole in the 1530 Part 4 where one of the thermocouples that was measuring the temperature inside the duct wasn't included in the FRL, and it just took a long time to change. So who does the specification of the fire and smoke control systems? Who, how, when, why? I can only look at the mechanical services consultant. I would think that if you design on the fly and you don't know what you're doing, you'll probably end up with a bucket of shit, basically. Pardon the pun. You love puns, don't you? So, yeah, I don't know. People are more than welcome to put their comments up and we can do a little summary, of them. But this is really for us to think about as industry because there are some changes. How's it been happening up until now? I don't know. I do know. But so when do we need internal, external or two-way fire protection? And if you specify two-way or you don't say and the certifier doesn't agree, you'll go with the external fire spray thickness, and that's going to add a lot of cost to buildings compared to what we used to. And we've had COVID and we've had GFCs and we've had interest rates and that. So we don't want any more developers. We don't want it to be any more expensive. So I think there's some room for us as industry to get together. And of course, there might be people in the US that watch this, and sorry, I should have included you earlier. AHJ, whether it's the authority having jurisdiction, is what we call our building surveyors or PCAs in Australia. And they ultimately validate the designs, or at least should be hopefully involved in the process of checking what's been signed off. So what we've done, and we put this big thing in here in our literature, in our manuals. We're saying that we've had a go. We're engineers. We got a license to be dangerous. And we thought, do we just keep this internally and then when people call, we'll just tell them what we think and show them how to save money? But it's not about that. It's about everybody getting on the same page, right? Let's face it, this is a change none of us wanted. So what we've done is we have taken the different clauses out of 1668 and the different types of ducts. And because it's strangely, 1668 nominates FRLs. Typically that's done in the NCC. I don't know how 1668 has been able to do that without the NCC's input, but it's obviously a very complicated standard. You can see some of these things have -3030, right? And they may be 1 or 2 or internal or external fire. That's not for us to say. We believe that if you look at it, there's a big cost savings there. We've done the same for blowing. So if you download the Fire App technical manual, for example, it's in there and it's just going into the Monaco duct fire spray manual. But they're only our views. Even if our view was right and you agree with it, the certifier might have a different view. 1668's pretty silent on it. It's very ambiguous. The more we read it, the more confused we get. No disrespect to my great mate Simon Hill, if you're watching or do get to see this, because you're chairman of that committee for Bruce Featherweather. People, everyone's having a go, and it's very slow to change the standards. So that was the blowing one. So that's really all I had today. I noticed that's going, a lot of questions coming through, isn't there?
Questions in there?
I'm sort of cautious of the time. We sort of gave ourselves a 45-minute time limit, but I just want to qualify and say that it is just to go. Oh, actually, we got a bit more, haven't we? Yes. So I want to summarise. Really important. So what have we talked about today? First and foremost, probably should have put up there, because if you don't remember anything and you just happen to watch this, that the FRL is the system, not the components. So when you see someone who says, I've got a 4-hour sealant or a 4-hour duct, it's not really. It's about an assembly, a system. It's the sum of the components. But what we talked about today was those ducts that aren't the non-rated ducts, that are dedicated ducts that turn on or do something special in fire and in the fire alarm mode of the building, fire and smoke control duct systems, again, that we test internal and external separately. If it is an internal and external assembly, I guess if you test it both ways, it's going to work both ways. But if you have to choose the thickness for both directions, you're going to have to take the thicker one. There you go. That's it. Why can't I see that now, Johnny?
That's a question popped up.
Yeah. I can't see my slide anymore. I should remember. Oh, yes. Design specification and certification needs some horsepower. We've got to, as industry, get together. Be happy to host, or somebody else can host, a workshop where we can get some really prominent mechanical services consultants, the NDYs, the Lincoln Scotts. I think of the old names, Omnis, God know who else there is. Sorry for naming companies that came to mind, and really get together and start talking about this. And what I will say, I just saw a marketing point in there. Trust Trafalgar, it just makes sense. If in doubt, seriously, we are playing with life safety, property protection. If you're not sure, there's no stupid question, Johnny, is there? We get questions. Never. It doesn't matter how qualified you are and how experienced you are. No one's going to bag you for asking questions. I ask questions all day, every day. And most of them are stupid ones. Question. So what was the question that came through, Johnny?
So the one that popped up on screen was, do we have any duct penetration systems through fire-rated ceilings?
Can you answer that?
I can. We don't have a deemed to satisfy system for this. We typically deal with these through performance engineering, where we draw up our recommended details depending on the exact ceiling system until we can get into the lab and do a specific ceiling test. So they're a bit trickier than usual barrier ceilings.
Yeah, I would say that it boils down to, it's a good one. We should put it on our listing. Who asked that? That's a good question.
It's Carl Davies.
Oh, okay, Carl. Very good question. I don't know. There's a lot of them. You get that far very often?
More often than we used to, actually. I don't know if architects are using more fire-rated ceilings for compartmentation, or it's just been picked up more. I'm not too sure.
Yeah. Well, that's a good one. I think we should have a go at that one. It'll open a can of worms, and it'll be 1 hour, 2 hour. Which brand of plasterboard's going so silly in the certification world? Size of the cavity. Yep.
The RSF ratings.
Won't be, we know it'll work, but we just don't have to test. Yeah, that's a really good one.
So Alan has said that Brett's taken over from Simon now.
Yeah, Brett Fairweather. Yes, I know that, Alan. Yeah, he's a lovely guy. His daughter is in the same year at the same school. You wouldn't believe it. As my youngest son, Alex.
Oh, there you go.
Yeah, at Oxford Falls. Yeah, he's a good guy, Brett. Oh, hello, Josita.
So Joe's saying that he believes it's the role of the design consultant to specify a product or system that can be approved at the building permit stage. And that's probably really important for design build practitioners. That's
Yes.
planning ahead and getting it all. Obviously.
So what's the term? Design consultant. Yeah, yeah. And yes, I was trying to say, who is that design consultant? Is he the mechanical design consultant?
I'm not sure.
Do builders actually engage them? Yeah, it's a really good point. I think I concur. I don't think it's for building surveyors. What a tough role. I have the utmost respect for building surveyors because they've got to know everything. They can't know all the details, so they have to rely on industry, have to rely on consultants, have to rely on manufacturers. I think the good old days are gone. There's a lot more checking needed to be done because the quality of work and workmanship, people just don't have pride in their work as much as they used to. That's shown my age, isn't it, Johnny? So, but it's they always say good houses are built on great foundations. So the earlier you get involved and the more design you do, and that's why I said earlier, get your building surveyor, whether he's a private or a council, get them involved. They won't bite you if they know what you're doing and they know where your pain points are. You're not showing them that it's going to cost you more money. They don't bite. And when we bring new products to market, I learned this a long time ago when I invented and patented and launched the first intumescent damper, and I got to the first job in Chatswood. It was a very young Alan Harriman and a very young John Rackick, and he said he got me. He said, I'm not certifying it in Chatswood because I've never heard of it. And I nearly jumped down the bloody lift shaft, or I nearly threw him down the lift shaft, and he said, I'm joking. But think of us. If it's new technology and you're going to bring it to market, and we've got to certify it, we've got to know about it. So, that's a bit of waffling, but it's, if you look at the Fire Code Reform Centre and the first fire engineering design guidelines, it's common sense. You bring the key stakeholders together early. And let's face it, if your building doesn't get signed off and you don't get a certificate of occupancy, you got nothing. So you'd want to make sure that the certifier, private certifier, building surveyor, principal certifying authority having jurisdiction, council, whatever it is across some of the curly areas. Better to find out up front and better to know about that, learn it on one job, so price it into the next job. But I do concur with Chandler. I'm sorry to bring him up twice, Dave, if you watch this. I'm not name dropping. But I just like the fact that, we really need to do some detailed design. Sadly for me, I work in passive fire protection. It's been singled out as one of the worst areas with waterproofing. That's terrible. That's why we're trying to improve it. It's probably because it's the lowest common denominator, but it's still important. So I hope that helps. Any more questions, John, or we'll cut it at, we've gone over it a little bit, or?
Yeah, look, that's all the questions. There's a few,
here we go. No such thing as internal only on kitchen exhaust via deemed to satisfy, but agree it needs to change. There you go. Who was that? That's a good question.
That's Gavin Williams.
Oh, okay. Yeah.
That's it. It shows that there's a big range of interpretations out there.
Yeah, I don't think anyone's looked at, Gavin, I don't think anyone's looked at the FRLs. I was on the ME62 Part 1 for years with Simon, Alan Obra, most people are probably retired now, and we talked about FRLs, and they said that's always the way it's been. I think it's the NCC's role, because they've told us in other standards, like AS 1851 is a great example when I wrote the passive section, where they said, you can't tell us the frequencies. You can tell us how to do it. We'll tell you how frequently you do it. That's why it took so long and it's never been called up. It's the same with 1668 Part 1. It should tell you whether it's internal or make a recommendation on whether it's internal or external or both. But the FRLs should be in the NCC, or at least the NCC should take a good, long, hard look at them, because if they're adding cost unnecessarily, then that's a problem for industry, because it's meant to be the minimum acceptable requirements to society, not necessarily utopia. We're struggling to build a deemed to satisfy compliant building. It's the minimum. So it definitely blocks innovation, Gavin, I'll agree with you. And so does a lot of other things, but it moves like it takes years to change a standard, sadly. And it's only the people that have a vested interest or have the energy, big companies, to go and go there. Okay, mechanical engineering practitioners. Okay, someone said that it's mechanical and required via the fire engineered report. Now there you go. This is why do we have fire engineered reports on a ridger? There's a question. It seems to me that everyone's passing on the liability. And, I was in the first group to do a master's in fire safety engineering in this country, and I realised that what I was signing myself up for, at least in the early days, around 96, 97, 98, was to just rip passive fire protection out of the building because the building's sprinklered. And I said, yeah, okay. So people are using the fire engineer to sign off on stuff-ups and just say the sprinkler's right. But why should a person who's buying a building get a building that's not built the way it was supposed to? It's a fact of life. We hear all the time. It's got to be in the FER, Fire Engineered Report. So we've got a long way to go. Let's face it, fire engineering is very young. Mechanical, civil, structural's been around for hundreds of years. So it's very young. Got a long way to go, but it's people listening to this that care that'll make the changes. Society, fire safety, industry, regulators. We don't want a terrible fire in a fire engineered building, and then all of a sudden, just like Kew Cottages in Melbourne, the government react and said every nursing home needs sprinklers in Victoria. We have a tragedy in a building where it kills some people, and it's blamed on fire safety engineering. You only have to look at what's happened down at Docklands with the cladding fire there. It got blamed on the fire engineer and the architect, and the insurance didn't like it, and the premiums go up. So it could be the death of fire engineering, sadly, or it might have a lot more controls than it needs. I think it's been a license to do whatever you want for a long time, and it's very hard for a certifier, if you're not a fire engineer, to validate models. But yeah, I knew the fire engineer had come up. I reckon that's it.
Well, that's almost bang on 1 hour.
Oh, we said 1 hour. I thought we said 45 minutes. But if you've got any more questions, email them through. What email?
Probably technical@tgroup.com.au. That's the one I sit on with my engineering team. If they get too heavy for us, we'll drag in John for some wisdom. You're also welcome to give us a call on the 1-800 number, where we can, even set aside some time to talk about specific issues or just more broadly continue this discussion. And I'm sure we will on some more LinkedIn Lives.
Yeah, we don't have all the answers, but we're just an ACOG in that big system, which is the building control and build right system, isn't it?
Yeah.
But I'm glad there's a few certifiers on, and I'm sure a lot of them will watch it. I just want to reiterate, I should have put in my summary, don't be scared of your certifier. They're there to help you. They can't get involved in the design, in inverted commas, but they can at least point you in the right direction if you're heading off in the wrong direction too early. When it's too late, it costs you too much money. So Big John and Small John are signing off. What I wanted to say at the start, and I forgot, I must have got stage fright. I was going to say, Kalimera, Kakusi. John, he cracks up. Kalimera, Kakusi, Buongiorno, G'day, how you going? Anyway, I'll say, like my old uncle Con the Fruiter used to say, how you going today? And have a nice day. If it's finished, you want to buy, Franco Cots on the far away.
Thanks, everyone.
Bye.